Hello everyone, I am Mrinal, Assistant Professor, MERI College of Engineering and Technology. In the previous two presentations, we understood the fundamentals of blockchain technology and then explored public blockchain in detail. Today, we are moving to the second important type of blockchain technology, which is private blockchain. In this session, I will explain what a private blockchain is, why organizations use it, how it works, advantages, disadvantages, and future scope. Let us begin. A private blockchain is a type of distributed ledger system that is accessible only to a limited group of participants, usually within a single organization or a consortium of trusted organizations. Unlike public blockchains, where anyone can join the network, view transactions, and participate in validating data, a private blockchain works on a permission-based model. This means that only approved and verified users are allowed to access the network, initiate transactions, and validate records. In a private blockchain, the organization controls membership and defines user roles and access levels. Some participants may have permission to read data, while others can write or validate transactions. Because participants are known and trusted, private blockchain use faster and more efficient consensus mechanism, resulting in higher performance and lower energy consumption. They are commonly used in banking, supply chain management, healthcare, and government systems where privacy, security, and regulatory compliance are important. Now, let's understand the key characteristics of a private blockchain in a more detailed way. The first characteristic is decentralization. Even though a private blockchain is governed by a specific organization or consortium, the data is not stored in a single location. Instead, it is distributed across multiple authorized nodes, which reduces the risk of a single point of failure and increases system reliability. The second characteristic is transparency. Unlike public blockchains where information is open to everyone, private blockchain ensures controlled transparency, which means only permitted participants can view transactions details, maintaining confidentiality while promoting accountability. The third important feature is immutability. Once a transaction is verified and recorded on the blockchain, it cannot be modified or deleted. This ensures data integrity and builds trust among participants. Another key characteristic is the use of efficient consensus mechanism such as PBFT or RAFT, which enable faster validation and decision making compared to public blockchain models. Finally, participation in a private blockchain is permission based. Only approved individuals or organizations can access and operate within the network, ensuring privacy, control, and secure collaboration among trusted members. This diagram illustrates the core building blocks of a private blockchain shown in this slide. The first component is access control, which ensures that only authorized participants can join and perform actions within the network. Next are smart contracts, which automate business processes and execute predefined rules without manual intervention. Private nodes represents the approved computers that maintain and validate the ledger. The consensus mechanism ensures agreement among nodes before adding transactions. Encryption and security protect sensitive data from unauthorized access. Finally, audibility and transparency allow controlled tracking of transactions, ensuring accountability while maintaining privacy within the organization. Now, we will discuss the steps involved in a building private blockchain platform in a more detailed and practical way. The first step is to clearly define the purpose and business objectives of the network. Organizations must identify the problem they want to solve, the stakeholders involved, and the expected outcomes. This helps in designing a system aligned with operational goals. The second step is selecting a suitable consensus algorithm that balances performance, speed, and security, ensuring efficient transactions validation within a controlled environment. The third step involves setting up the network by conferring nodes, infrastructure, and permissions for participants. After this, the organization chooses an appropriate blockchain platform that supports scalability, flexibility, and enterprise level feature. Step 5 focuses on designing smart contracts that automate workflows, agreements as business rules, reducing manual intervention. The next step is implementing strong security measures such as data encryption, identity management, and access controls to protect sensitive information. Finally, the network is deployed and continuously monitored, updated, and optimized to maintain performance, reliability, and long-term efficiency in real-world operations. Now, let us understand the working of private blockchain. Unlike public blockchains, access is restricted to approved participants. An organization creates and manages the network, selecting who can join, what permissions they have. Transactions are verified by authorized nodes, ensuring speed, privacy, and efficiency. Once validated, data is securely recorded on a distributed ledger. This structure makes private blockchains ideal for business needing transparency, security, and controlled collaboration. Now, let us discuss some real-world platforms for private blockchain. First is Hyperledger Fabric, a widely used private blockchain platform. It is an open source framework designed specifically for enterprise solutions. Hyperledger Fabric uses a permissioned network, meaning only approved participants can access and validate transactions. Its modular architecture allows organizations to customize components based on their needs. It supports smart contracts called chain code and ensures high scalability and privacy. Many industries use it for supply chain, finance, and healthcare applications. Next is R3 Corda and IBM. Blockchain, two major private blockchain platforms. R3 Corda is designed mainly for financial institutions, enabling secure and private transactions between trusted parties. It shares data only with relevant participants, improving confidentiality. IBM blockchain, built on Hyperledger Fabric, provides enterprise-grade blockchain solutions with cloud integration and strong security. These platforms help business improve transparency, efficiency, and trust in areas like banking, trade, and logistics. Quorum, developed by JP Morgan, is an enterprise focused version of Ethereum designed for high speed and enhanced transaction privacy. It supports permission access and private smart contracts. Multi-chain, on the other hand, is built for simplicity and flexibility, allowing organizations to quickly create and deploy private blockchains. Both platforms are widely used in finance, supply chain, and enterprise data management system. Now, let us discuss some benefits of private blockchain. Enhanced security is achieved because access is restricted only to authorized participants, reducing risk of unauthorized transactions and cyber threats. Improved performance comes from a limited number of nodes validating transactions, which result in faster processing and minimal delays. Scalability allows organizations to expand the network as needed without affecting efficiency. High throughput ensures that large volume of transactions can be handled smoothly, making it suitable for enterprise environment. Increased trust is developed among participants because all the members of operate within a verified and controlled ecosystem. Energy efficiency is the another key advantage, as private blockchain do not rely on intensive mining processes like public networks. Cost effectiveness is achieved by reducing intermediaries and automating processes, which lowers operational expenses. Flexibility allows organizations to customize rules, permissions, and governance structure based on their specific requirement. Control over the network ensures that sensitive data is accessed only by authorized members, supporting confidentiality and accountability. Privacy is maintained through permission based participation, protecting organizational and user information. Regulatory compliance become easier because policies and legal standards can be embedded into the system, enabling transparent audits. Collaboration is enhanced as multiple departments or partner organizations can securely share and verify data in real time. These benefits make private blockchain a practical and efficient solution for industries like finance, healthcare, logistics, and government sectors where trust, security, and structured collaboration are essential for smooth operations. Now, let us move toward the use cases of private blockchain. Private blockchain is widely used across industries for managing complex operations securely. In supply chain management, it helps track products, ensure authenticity, and improve coordination among stakeholders. Financial services use it for faster settlements, fraud prevention, and secure transaction processing. Healthcare organizations apply it to manage patient records, ensuring privacy and control access. Identity management system benefit by providing secure digital verification and reducing identity fraud. Digital rights management ensures ownership and distribution control of digital content. Voting system can use private blockchain to maintain transparency and prevent tampering while keeping voter information confidential. Insurance companies use it for the claim processing and for fraud detection. These use cases demonstrate how private blockchain enables organization to enhance efficiency, transparency, and trust while maintaining strict control over sensitive data and operations within a secure network environment. This explains the major advantages of private blockchain technology in organizational environment. First is high efficiency. It is achieved because transactions are validated by a limited number of trusted participants, resulting in faster processing and minimal delays. Second is data privacy is maintained through permission-based access, ensuring that sensitive information is shared only among authorized users. Third is cost effective. The system is cost effective as it reduces dependence on intermediaries and automates many operational processes. Fourth is regulatory compliance becomes easier since rules, standards, and audit trials can be built directly into the network design, helping organizations meet legal and governance requirements. Fifth is a customizable network allows institutions to define their own protocol, permissions, and access levels based on their operational needs. These features make private blockchain particularly suitable for enterprises, financial institutions, healthcare organizations, and government sectors that require secure, reliable, and controlled data management while the maintaining operational efficiency and trust among participants. This highlights the limitations associated with private blockchain system. One of the main drawback is less decentralization as the network is controlled by a specific organization or consortium rather than being open to all participants. Next one is the structure required trust in a central authority that manages access, permissions, and governance. Also, the system is not fully transparent compared to public blockchain because data visibility is restricted to selected members only. There is also a risk of internal manipulation if governance policies are weak or if decision-making authority is concentrated within a small group. Additionally, dependency on organizational control can reduce the overall democratic nature of public blockchain. These challenges emphasize the importance of strong governance frameworks, clear accountability, and security protocol to maintain fairness and reliability. Organizations must carefully balance control and decentralization to ensure the private blockchain remains trustworthy and effective for long-term operations. The future of private blockchain is becoming increasingly promising as organizations across industries recognize its value for secure and efficient digital operations. Enterprise adoption is steadily growing because business require reliable system for data sharing, transaction management, and internal collaboration. Private blockchain provides the control, privacy, and scalability needed to support these requirements. Another major trend is the integration of blockchain with emerging technologies such as artificial intelligence and the Internet of Things, which enables smarter automation, predictive analytics, and secure machine-to-machine communication. Governments are also exploring private blockchain for the administrative services, digital record management, and the transparent governance system. In addition, secure digital identity systems are expected to expand, helping individuals and organizations manage authentication and protect personal information. As regulatory frameworks become clearer and technology continues to mature, private blockchain will play a vital role in building trust digital ecosystem. It will support innovation, improve operational efficiency, and strengthen security across sectors like finance, healthcare, logistics, and public administration. This explains the difference between public and private blockchain system. Public blockchain is open to everyone, meaning anyone can join the network and participate, while private blockchain is restricted and require permission to access. In public networks, every node has equal authority and helps validate transactions, whereas in private system, only selected participants perform validation. Public blockchain transactions are generally slower due to large network consensus, while private blockchain offers faster transaction processing. Public blockchain has higher transaction cost and energy consumption because of complex consensus mechanism, while private blockchain is more cost effective and energy efficient. Public networks often use proof of work or similar methods, while private systems rely on pre-approved validators. Users in public blockchain can remain anonymous, but private blockchain participants are known and verified. Public blockchain require trust in technology and decentralization, while private blockchain requires trust among members and the governing authority. Overall, public blockchain supports openness and transparency, while private blockchain focuses on privacy, control, efficiency, and organizational collaboration. In conclusion, private blockchain is transforming how organizations manage data, build trust, and collaborate securely. It offers the right balance of privacy, control, transparency, and efficiency required in today's digital environment. As adoption continues to grow, it will play a vital role in driving innovation, improving operations, and supporting secure digital ecosystem across industries. Thank you for your time and attention.